Hey, good morning or good afternoon now. By the time this is uploaded, it'll definitely be afternoon. So I just wanted to get on here real quick and share a little bit more about the long range forecasts and what I'm seeing as far as, well, the weather. But first, I wanted to point this out to you that every single county, not only in North Carolina, but in South Carolina, has snow on the ground. That is pretty cool. That is pretty cool. And you can kind of see some of the, this was from the upper level low, and this is from the coastal low. So, and then like we said in those forecast videos, what happens up here, what happens down here, and what happened in there. Woo! Some of these places got walloped. Well, now that storm has moved on, and now we are going to look to the future. So, over the next couple of days, we would not expect too much in the way of precipitation, except up here in the mountains of West Virginia. That will mostly be snow. The next system is what's in question. I've seen some forecasts where it produces some snow again for the Carolinas, but I am weary of such forecasts, and I'll show you why. We're going to start out here with the AIFS, the AI version of the Euro model. And this is beginning Monday evening. So this system is out to sea now. We have this developing low pressure center in the panhandle of Texas. And as we push this forward, don't fuss at me. As we push this forward, you see that this high pressure center and this low meet up, and Lowe's actually love, not Lowe's, the store. The low pressure centers love temperature gradients, and you can see these red lines go to blue lines, and they're tightly packed a little bit here. That's baroclinic. That's a baroclinic zone. So that's a temperature difference in the horizontal. Whenever you have temperature differences in the horizontal, the amount of energy released can be pretty big, because what we've seen just off the coast of the Carolinas, typically you have those bombocyclogenesis or bombogenesis that people like to say. It's just pretty much a millibar drop in pressure every hour. And if you think about what happens off the coast of the Carolinas in the wintertime especially, you have the Gulf Stream, which is very warm waters from the Gulf and from the Caribbean, meet up with the colder air of the Arctic blasts, especially that we've been having this year, and it creates a natural occurring baroclinic zone, or a sharp temperature difference across the warm Atlantic Ocean and the cold land across the Americas or United States. And this creates a whole bunch of energy. And if you have a piece of upper level energy that just happen to occur to rotate around and induce cyclone genesis off the coast of the Carolinas because of the temperature difference, you got a lot of energy released. And from the reports that we've seen and that you've seen, more than likely, it was pretty bad out in the outer banks of North Carolina. But anyways, that's just a little bit of meteorology for you. So we have this low pressure center along this frontal system, very weak frontal system to the north of that. But this low pressure center in the Ozarks will slide eastward, and as it does so, it'll bring chances of rain, I believe, to the mountains and the Carolinas. And these blue lines here, the 540, it's 500 or 5,400 decameter thickness lines. This is the traditional rain snow line. Now, does that mean anything south of that is rain? No, doesn't necessarily mean that. But on this particular map, it's a good indication of where the atmosphere could support snow and where it could support more of a liquid precipitation type. If we pull this forward a little bit more, we do have that rain snow line infiltrate the mountains and then the Piedmont and all the way towards the coast. And for some reason, it kind of looks like what happened just just this past while ago. This just looks like what happened across the Carolinas this past weekend, where moisture gets hung up from the upper level system. But this upper level system here is considerably weaker. So I do not believe that the moisture field will have such a response like this to the weakness of the upper level system. So that's the AI Euro model. If we look at something else like the GFS, the AI GFS, it has something very similar. Moisture being brought in from the Atlantic, just sucked up from this upper level system. Again, this is, it's a little sharp, but it's weaker than what we had just a while ago. It's weaker than this last system that we've seen now. The AI models agree with this, but the surface temperatures are warm. So the surface temperatures here are above freezing. So even though the atmosphere could support snow, in the grand scheme of things, the 1,500 millibar thickness, the atmosphere could support snow. That doesn't necessarily mean it will snow. Now let's take a look at the GFS, the actual GFS. So this is the dynamical GFS. No AI. This is purely physics. Again, it has pretty much the same thing. Low pressure from the panhandle of Texas, marching eastward across the Ozarks into the Mississippi River Valley, Ohio River Valley. And then this time, a lot less of a response. I'll say that. A lot less of a response to the precipitation field across the Carolinas. If we take a look at another model, how about the actual Euro? The European model, which is pretty much, this is a pretty good model. This does not have such a precipitation response across the Western Carolinas and upstate South Carolina. Maybe an argument could be made a little bit towards the coast, but not a lot. Not a lot. And then the Canadian model, the GEM, does have some response. The surface temperatures are going to be an issue with these this next system. I believe it might be too warm for snow. All right, so looking out even further than this, here is our Arctic blast that gave us some pretty hefty snows across the Virginias and Carolinas. If we go forward, this is the 2-meter temperature anomalies for this time of year, 5-day averages. We can kind of see if you had followed along in the earlier videos. We used to do this a lot. We used to look at these maps a lot with the weekly, when I used to do these weekly videos, but time is not been on my side here lately. But you can see these air masses a lot better for the 5-day average anomalies for the 2-meter temperature. So you can see these air masses, the cold Arctic air masses, and then the warmer air masses. And as we move this forward, you can see how these air masses will move and modify. So this Arctic blast over the next 8 to 12 days will lift northward and slightly modify. Meanwhile, a massive amount of warmer air on average. So you see these warmer colors over the Canadian prairies, but that is on the order of 8 to 12 degrees Celsius higher than normal. So it's still pretty cold up there, but it's just going to be warmer than average. This warmer than average air stretches all the way from really Alaska down through the Rockies and into the Gulf and into Mexico. And meanwhile, this colder air mass stretches pretty much on the outer edges of that from the southeastern Canada into the northeastern United States, across the eastern seaboard into Florida, Cuba, the Bahamas, and into Central America. That's pretty cool. As we move further along, you can see across the southeastern United States and the mid-Atlantic, we're going to be warmer than average going into the middle part of February, between days 11 and 15. So if you're tired of the cold weather already, relief is on the way. And it's going to come into a form of warmer temperatures, which is how you spell relief from the cold. So to wrap up, I believe it's not going to snow anymore, this year at least. Nah, I'm not going to say that. I want to say this next system isn't going to be that snowy. Yeah, sorry. If anybody was looking for some more snow, I don't see it right now. Hopefully the next video will have more good news for you. But in the meantime, I hope you guys enjoy the snow. Be safe out there, and I will see you later.